This video will show you the 4 steps of running a hypothesis test for population proportion. An example problem, the accounting department of a major state university would like to advertise that more than 50% of its graduates receive a job offer before graduation, and a sample of 260 recent graduates, 138 indicated that they had a job offer prior to graduation. How can the accounting department test their claim? They can do this through a hypothesis test, hypothesis testing for population proportion. The first step here would be to set up the hypotheses. There will always be 2 hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis will always use an equal sign, and the alternative will use some inequality, greater than, less than, or not equal to. In this case, we'll use greater than because that's what the accounting department wants to prove, that more than 50% of their graduates receive a job offer before graduation. So alternative, that's the one the researchers are trying to prove, and then the null, you just use an equal sign instead. Step 2 would be calculating the test statistic. There's a formula for this in your formula sheet. This is it. P hat would be a sample proportion. P, that's the value used in the null hypothesis. Q is just 1 minus P, and N would be the sample size, which in this case was 260. So filling this in, I think P hat would be 138 out of 260, minus 0.5, which was what the hypothesized value for P was. And then this would be 0.5 times 0.5 over 260. So again, P and then Q is just 1 minus P, so they both end up being 0.5. And I believe this gives you 0.9935. So that is the test statistic. I'll put an interpretation of this in the description of the video. Next step would be to calculate the p-value, and to do this you would plug the test statistic into the normal calculator, not the t calculator, for proportions, and then shade appropriately. Deciding which direction to shade, I guess there are a few ways you could do this. I think the best way is usually looking at your alternative hypothesis. If it uses a greater than sign, you would shade to the right. If it uses a less than sign, you would shade to the left. If it uses a not equal to sign, then I think you want to shade in the normal calculator such that the red tail is the smaller red tail. So here's the normal calculator. I'm going to shade to the right, plug the test statistic in right there, and this would be the p-value, 0.1602. Again, if this had been a two-tailed test, you'd want to shade to the right just because you want to have a smaller red tail. You don't want to have something like this. So the p-value would be 0.1602. And then the last step would be reaching a conclusion. And to do this, you compare your p-value to a given significance level, even though I didn't give you one here. Compare the p-value to alpha, which was a given significance level. We'll just say 0.05. It's typically something around 0.05, maybe 0.1, maybe 0.01. But in this case, p-value is greater than the significance level, so your conclusion would be fail to reject the null hypothesis. And then there is insufficient evidence to conclude, and I'm just going to write in brackets H sub A, the alternative hypothesis. Here you want to actually put the alternative hypothesis into words. So there's insufficient evidence to conclude that the proportion of students who receive job offers before graduation is greater than 0.5. So I'll include this description or this conclusion in the description as well. But that's all there is to the test.